got cut off a little bit on that last one, so let me finish up. Remember, this is division. Subtraction only applies to the exponents. So if it's just regular numbers, we're going to divide that. 24 divided by -4 is -6. And then for A, this is where we can use our exponent rules. Remember, if a base doesn't have an exponent, its exponent is 1. So we end up with -6 times A to the 7th power. This week, we're going to be looking at a little bit of a different situation. So first, let's just look at these two examples. This one should look familiar. It's similar to the ones we did last week. Again, if we were to expand this out, we would have 3 times 3 times another 4 3s. 1, 2, 3, 4. And that gives us a grand total of 6. This is the example where we take the two exponents and add them together. But this doesn't quite look like that. Here we have two powers with the same base, but here we only have one power, and it's being raised to another exponent. It doesn't work the same way. I'm not just going to add those two exponents together. So what do? Well, if I were to expand this out, 3 squared to the 4th power would mean this is my base, and I'm multiplying it with itself 4 times. So we would have 3 to the 2nd power 4 times. And notice I'm multiplying that because that's what exponents tell us to do. And that leaves me with 2 3s here, 2 3s here, 2 3s here, and 2 3s here, or 3 to the 8th power. Now, I want you to be keeping that in mind. What's the relationship between 2 and 4? Oh, 2 times 4 is 8. So if we look in our books, that's going to be our next property. We have two options with these types of problems. We can do like what we did above, and we can expand it. So 5 squared to the 3rd power would mean this base, 5 squared, multiplied with itself this number of times. And when I do that, I see, okay, I have 2 5s here, another 2 5s, another 2 5s, for a total of 6 5s, 5 to the 6th power. But the other way to do it, the shortcut is I multiply the exponent with the power it's being raised to. So 5 to the 2 times 3 is 5 to the 6th power. And this property is known as the power of a power. So let's look at another one. Instead of me expanding all this out, that would take me a lot of time. All I have to do is -2 to the 7 times 10 equals -2 to the 70th power. This property is just as easy to do as the previous one. The only thing we want to be careful of is knowing when it's this one versus this one. And the easiest way to remember it is here, there's going to be two separate powers, and here it's an exponent being raised to an exponent. Let's look at one more example here. This time we have a power being raised to a power to another power. So what do we do in this type of situation? We still just multiply. I take all the exponents, multiply them together. 3 times 2 is 6, times 2 again is 12. And that's our answer. Let's go ahead and see how the book explains it. Notice they break it down the same way. 6 to the 4th to the 5th power is 6 to the 4th 5 times. Using the product of power rule we used last week, we see that we add all those 4s together and we end up with 6 to the 20th power. Notice that is the same as if I multiply 4 and 5. That's how this property works. We're going to go ahead and do the examples on page 32 together in just a second, so hold tight.